Hello, I am Sebastiano Tomassetti, a fellow researcher of Marseille Polytechnic University in Italy, and today I'm going to present you a foldable and portable solar cooker that was specifically developed to be suitable for humanitarian and refugee camps. Globally, millions of people need humanitarian help or are forced to stay in refugee camps due to natural disaster, severe weather events, conflicts, or wars. However, the cooking methods usually adopted in this context are inefficient and unsustainable. An example is the intensive use of firewood that can result in health issues and premature deaths due to air pollution, or deforestation, environmental deterioration, or even safety issues. Therefore, solar cooking is a promising environmentally friendly alternative that can prevent these harmful effects on health and environment. The spread and use of solar cookers in the humanitarian aid context face different issues related to the humanitarian logistics, such as the transportation, storage, and delivery of these devices have to be optimized to avoid hindering the humanitarian operations. Their dimensions and size must be compatible with the capability of vehicles and facilities used in this context in order to also maintain their original integrity and quality, and finally, their transportation should be cost-effective. However, these aspects are not usually taken into account during the design of solar cookers. For this reason, a foldable and portable low-cost solar cooker was specifically developed for humanitarian and refugee camps by taking into account the aspects described above. It was designed by Matteo Muccioli, one of the authors of this presentation, and was also patented. As shown in the figure at the top, the solar cooker comprises a trapezoidal cooking chamber, the bottom and three sides consisting of wood panels, while the top and the other side comprise glass layers. It has also reflector panels on the sides that can be adjusted to maximize the concentrated solar radiation in the cooking chamber. The components of the cooker can be easily disassembled to be stacked as shown in the figure at the bottom. In particular, due to the limited dimensions and mass of the foldable prototype, it is possible to transport about 124 closed devices in a Euro single pallet. The performance of the developed solar cooker was experimentally evaluated by performing outdoor tests at our university in Italy in spring and summer of 2022 and 2023. Particularly, these tests were carried out without load and with wood and glycerin as testing fluid by using a glass enclosed pot as receiver that is shown in the figure at the top. And since the obtained results were presented in the paper reported in the slide, in this presentation only the main outcomes resulted from the test are summarized. In particular, it is possible to note that despite its low power and relatively long time to heat the tested fluids, the device was able to cook a different type of food with acceptable time. In order to overcome the limitations of the device emerged from the experimental analysis, a new version of the solar cooker was designed and manufactured with the aim to improve its cooking performance by changing its design and materials, ensure its complete portability by developing a fully foldable and lockable device, but also to completely assure food compatibility of the device by using food-grade materials. The development of the improved portable solar cooker was carried out under a proof of concept project funded by the Next Generation EU project. The first step to develop the improved solar cooker was to experimentally study different configurations of the original prototype by using an indoor solar simulator that simulates the sun at its zenith with a solar irradiance of 850 watts per square meter. The use of this simulator was necessary to perform tests with repeatable conditions, suitable for testing the studied solar cooker, since this analysis was carried out in winter. In particular, 3 different configurations were tested in addition to the original. The first configuration comprises the cooking chamber covered with aluminum sheets painted with a black coating. Instead, the second comprises the cooking chamber covered with reflective aluminum sheets. Finally, the third configuration comprised the cooking chamber covered with reflective aluminum sheets and also 2 additional reflectors at the back of the prototype. Tests were carried out without load and also by using a glass enclosed pod as receiver, and for each test the receiver temperature and the ambient temperature were recorded, and also the first figure of merit F1 was calculated as the difference between the maximum receiver temperature and ambient temperature divided the solar irradiance. As evident from the behaviors of the receiver temperature as function of the time shown on the left and the values reported in the table, all 3 new configurations ensure better results than the original prototype, corresponding to configuration 0. However, the cooking chamber covered with the reflective material corresponding to configuration 2 ensure higher temperature than configuration 1 that represents the cooking chamber painted in black. Instead, as expected, the last configuration, with the additional reflectors, provided the highest temperatures. Then, an improved prototype was developed on the basis of the results of the indoor test. But the new design took also into account economic and technical aspects related to its large-scale production, such as the use of easily available materials and the standardization of the process of manufacturing. As shown in the figure in this slide, the main improvements of the new version with respect to the original prototype are that it comprises 2 additional reflectors at the back. Its cooking chamber is covered by reflective aluminum sheets on the sides, while a movable aluminum sheet is placed at its base. This sheet at the base is reflective on one side, and it is coated with black Teflon on the other. This second side can potentially allowed to directly put food on it when a glass enclosed pot is not available. Finally, the design of the solar cooker was modified to ensure that the folded configuration is a closed box easy to transport, as shown on the figure at the bottom. In fact, all the components of the device can be stacked in its base, and the back wooden panel of the cooking chamber can be folded to close the box. To test the usability of the new device, 24 prototypes of the improved solar cooker were manufactured and shipped to users in different Italy regions, as shown in the map on the slide, together with a feedback form to perform a satisfaction survey. In particular, users with limited or no experience in solar cooking were selected in order to have a more reliable feedbacks. However, we are still collecting the results of the survey that will help us to optimize the design of the solar cookers, but the first feedbacks from the users highlighted some issues with its use due to the difficulties in the correct orientation of the reflectors. As part of the activity of the proof of concept project, a simplified and more economic version of the portable solar cooker was developed for developing countries. In fact, the simplified prototype only comprises a cooking chamber obtained from a wooden box without a glass cover on the top, and it also has 2 reflectors made of reflective plastic material glued on wooden panels. However, to improve its thermal performance, The receiver developed for this device is based on the Norwegian pot. In fact, it comprises a pot with a glass lid on the top, and it is covered by recycled cotton rags used as a thermal insulator. Also in this case, 6 prototypes were manufactured and shipped to families in Tanzania to test on the field its usability. However, we are still waiting their feedbacks. Thank you for your attention.